Hey, Thomas Dimitrovich here for IAEI News Live. Today's a recorded session, and hopefully you got something out of last week's. We're coming off of talking about some wiring devices, got a little exposure to how we do things in other countries. But this week, I want to focus on another standard product, something that we see pretty much every single day, and that would be the basic transformer. Today's topic, transformers, and it starts now. All right, welcome to the IAEI News Live. Let's get started. So, today we're going to talk about transformers. You know, the transformer is one of the most commonly used pieces of equipment in a power distribution system. When it gets down to the fundamental and the value of alternating current, we find the use of transformers. Being able to distribute power at one voltage, utilize it at a different voltage. And in some cases, take the transformer and use it as a means to isolate one part of a power distribution system from another electrically. Maybe not physically, but electrically. So, in any case, transformers are a key piece of our lives as power distribution, in the electrical industry. I was going to say power systems engineers, but inspectors, installers, contractors, doesn't matter what you're doing. If you work in the electrical industry, you are going to come across a transformer. So let's just take some time and walk through transformers. All right, so we're going to base our discussion on the 2023 edition of the National Electrical Code. So just keep that in mind that we're going to be focused on the 2023 code. So get your 2023 code book out, or even better yet, go out there and grab your tablet or your computer or even your phone and call up NFPA link. So, in fact, that's what I'm going to do right now. I'm going to go to nfpa.org. There we go. So from nfpa.org, I'm going to come up here to the very top corner, right next to catalog, and click on NFPA link. Now I've already logged in, so it's part of my browser. So it remembers who I am, which is another value proposition of the whole tool. And as you can see, I have access to a lot of different documents. We're going to focus on the 2023 edition of the National Electrical Code. All right, so I have my copy of NFPA link open up over here, and we're going to just talk about the transformer. You will see transformers come in all different shapes and sizes. Basically, an enclosure like this you might see, and different locations, whether it be outdoors or indoors, right? Inside of a transformer like this, which might be located, in this case, it's located clearly outdoors. You have ventilation. You have to remember that little notch there at the top is not a place to insert your garbage or other items, because there are exposed electrical parts right down below that. They can be very small transformers as well. They don't have to be large power distribution system hunks of iron. You'll find these types of transformers in residential dwelling units, maybe for doorbells and things of that nature. So transformers are a part of our power distribution system applications for sure. In any case, this case here, this is a relatively small transformer that's located on the wall and mounted on the wall. You won't necessarily see transformers just mounted on the floor. You can see these devices, this equipment being placed on walls or up in behind drop ceilings and things of that nature. And we'll get into the whole concept of working space as well. So so that's just a close up of that installation. You'll see that it has a listing mark. It is listed, and it has the diagram for the transformer that is enclosed inside, and all of the pertinent information necessary for the proper application of that product. This is another one. So now again, I'm just showing you different types of transformers. And we just saw one of these. This was something, a similar transformer, previous picture, was shown on an outside installation. This is on an indoor installation. And I will add that these transformers can be located in a lot of different locations, a lot of different places. All right, so when I look at a transformer like this, what comes into question is whether or not the NEC applies to a beast like this. And really the determining factor is not the size of the equipment, it's not the voltage of the equipment. The deciding factor on whether or not the NEC applies in this application is really around the scope of the document and who owns that equipment. So if we go to Article 90 of NEC, the 2023 edition of the NEC, you'll see in Article 90, you have a scope, you have the use and application in 90.2. A covers the practical safeguarding, the goals and the purpose of the code that addresses the practical safeguarding of persons and property from the hazards of electricity. You have in 90.2b the adequacy for the provisions that are basically, it tells you that that the code contains provisions that are considered necessary for safety and free from hazard, right? But again, it tells us that it's not necessarily efficient, convenient, or adequate for good service or future expansion of the for electrical use. Now, future expansion, again, that's another area where you might see a transformer sized larger than what you think is needed for the application. And it could be that the design engineer or the owner is anticipating growth of the facility, so they put a larger transformer initially so that they don't have to change something out in the future, right? That would be something that would be a design decision and not necessarily driven by a code requirement. So keep that in mind. But what I was trying to get to was 90.2C, installations covered, and D, installations not covered. Now, this tells you that the installations that are covered include public and private premises, including buildings, structures, mobile homes, recreational vehicles, floating buildings. They cover yards, lots, parking lots, carnivals, installations of conductors and equipment that connect to the supply of electricity. And as you'll see in a little bit, a transformer does meet the definition of equipment. So a transformer is equipment. Installations used by the electric utilities such as office buildings, warehouses, garages, machine shops, and recreational buildings that are not an integral part of a generating plant, substation, or control center. So the code does apply to the electric utility installations, but again, that when they're not an integral part of a generating plant, a substation, a distribution substation, or a control center. Also, installations supplying shore power to ships, etc. Now, what's not covered? There's a list of, I believe, 5 items, right? So you have installations in ships, watercraft. That's not basically what we're looking at here. Underground in mines, self-propelled mobile surface mining machinery, and its attendant electrical trailing cables. Installations of railways for generation, transformation, transmission, energy storage, or distribution of power used exclusively for operation of rolling stocks, or installations used exclusively for signaling and communications purposes. Item 4 is installations of communications equipment under the exclusive control of communications utilities. That's definitely not a communication piece of equipment. And then installations under the exclusive control of an electric utility where such installations consist of service drops or service laterals and associated metering that are on the property owned or leased by the electric utility for the purpose of communications, metering, generation, control, transformation, transmission, etc., are located in legally established easements or rights of way, located by other written agreements or designated by or recognized by public service commissions, utility commissions, or other regulatory agencies, etc. So the bottom line for this type of an installation that you might say, well, that's a utility transformer and it doesn't apply. If it is truly a utility transformer, then I would agree that NEC does not apply. But when it does apply is in the when that that type of a transformer might be customer owned. And you might say, well, when would a customer own that equipment? Well, I would argue that some heavy commercial, heavy industrial applications might own that size of a transformer. So you have to be careful when you're trying to determine whether or not the NEC applies to equipment, and it will depend upon the application or the ownership of that equipment. And you've got to go back to Article 90, specifically Section 90.2, to determine when the NEC applies or does not apply. And if it doesn't apply, you have to figure out what would apply. All right? All right, so let's take a look at the definition of the transformer, which is found in Article 100. Now, it was tweaked. It was modified a bit. What I'm showing on the, I'm showing here, geez, my code book is coming apart. What I'm showing here is the definition that is found in the 2023 edition of the code. Let's take a look at the definition in Article 450. Remember, previous editions, the definitions were found in the .2 area of different articles. Now, 450.2 included a definition of a transformer, and it says, an individual transformer, single or polyphase, identified by a single nameplate, unless otherwise indicated in this article. That is the definition. What you find in the 2023 edition is that it's equipment, either single or polyphase, okay, single or polyphase, that uses electromagnetic induction to convert current and voltage in a primary circuit into current and voltage into a secondary circuit. So it expanded a little bit more on the definition of what a transformer is as part of the 2023 code cycle. And it brings forth the concept that you have induction, electromagnetic induction, and that you might be converting current and voltage in the primary into current and voltage in the secondary. It doesn't say whether or not it's stepping it up or stepping it down, because you don't necessarily have to change a voltage or current, right? You can have a specified kVA, and it can be a one-to-one transformer, but to isolate for isolation purposes, or possibly to knock down available fault current to equipment downstream. So there are multiple types of transformers, and a transformer does not always have to transform one voltage to a different voltage. It can be a one-to-one transformer. So just be mindful of that. And I think that the new definition adds some clarity in that regard. Now, the transformer is also, it meets the definition of what electrical equipment is. Equipment is defined, the term equipment is defined in the NEC as a general term that includes fittings, devices, appliances, luminaires, apparatus, machinery, and the like used as a part of or in connection with an electrical installation. So the transformer is equipment, and that's an important distinction, because when you see requirements that impact quote unquote equipment, you've got to throw transformers in there as well. Remember, the code book includes a lot of many requirements that impact equipment. They won't specifically call out a transformer. A good example of that is working space. So in 110.26, 110.26 covers working space. So if you go to 110.26, now keep in mind that 110.26 is in the 1000 volts nominal or less. And the references that I have here specifically pertain to transformers or equipment, right? 1000 volts nominal or less. But in that's in part 2. In part 3, for over 1000 volts, these requirements are also there as well. And I would argue that there are about 3 requirements, 3 sections. Like for example, here we have depth, width, and height is covered by 110.26A1, A2, A3. But in over 1000 volts, in that section, you'll have spaces about electrical equipment in 110.32. And then you'll have entrance or enclosures and egress in 110.33. And then you'll have working space in 110.34. So the difference between the low voltage and the medium voltage application or the code requirements are that they don't structure the requirements exactly the same. You have to go to 3 different sections to find the answers or find your requirements that in the low voltage in part 2 is all found in one section. So, and I'll show you those sections a little bit later. But if you look at 110.26, the language, it says spaces about electrical equipment. And like I said, transformers are electrical equipment. So you have to follow the working space rules that you find in 110.26, although they don't specifically call out a transformer. Okay, so just keep that in mind, that you do have to follow the rules for working space and spaces about electrical equipment for transformers, even though the word transformer is not found in 110.26. Now, what 110.26 tells us is you have to think about access to and egress from the working space. But, and again, 110.26 is pretty generic. And we did put in the 2023 code cycle the discussion about open equipment doors not impeding access to and egress from working space. That wouldn't necessarily apply to like a dry tie pad mounted transformer because you don't typically have doors on that. Now, if the transformer is located inside of an assembly, which is possible, your transformer does not necessarily need to be in its own standalone enclosure like we saw earlier in those pictures. It very well could be that a transformer is located within, say, a switchboard assembly. In that case, the access to that transformer will be a larger door that you may open. And you have to consider that open doors cannot impede access to and egress from the working space. And remember that that the way the language reads in 110.26 today, because this was changed in the 2023 cycle, you also have to consider simultaneously opened equipment doors. So if you have equipment on either side of, say, a hallway, for example, you have to consider opening the doors on both sides of the hallway, and you can't impede egress to, and you can't have a space that is less than 24 inches wide or 610 millimeters wide, right? And 6.5 foot high and 2 meters or 2 meters high. So you've got to think about the electrical worker who's going to be working on that equipment. Now, I haven't even talked yet about which is here. You'll look at the limited access requirements that are found in 110.26A4 your limited access in A4 talks about when you have equipment that is installed, say, above a ceiling. In a lay-in ceiling, there shall be opening not smaller than 22 inches by 22 inches, or in a crawl space. Transformers can be located in those applications as well. So you have to think about where you're going to place your transformer, whether it's going to be up high, whether it's going to be on a mezzanine, whether it's going to be in a crawl space, above a ceiling, etc. And you have to have the requirements, and you have to meet the limited access requirements that are found in 110.26A4. Now, also, and I think another big violation around transformers is something you might find in 110.26B. Working space required by the section shall not be used for storage. And we cover some requirements back in 450, which we'll talk about. Transformers, I mean, they have a nice flat surface on the top, and unfortunately, that seems to be the place to set things, right? Any flat surface is going to get equipment piled in, especially if if a transformer is located, say, in a closet or in a electrical closet. It's very compelling. We seem to be an industry where we're compelled to put things on top of any flat surface that we can find. So keep in mind, clear spaces, working space, the working space itself as well cannot be used for storage. Now the working space would not include that flat surface on top of the transformer, but again, we cover that in Article 450. There we go. So in 450.9, so here's the thing. When you think about what we have in 110.26B about clear spaces. This is the space. This is passageway, this is your general working space. You don't want anything in there. From the top of the transformer's perspective, you've got to go back to 450.9, which is titled ventilation. So remember, transformers are designed to have to give off the heat. And what we put in 450.9 for transformers was a sentence. In the 2020 code, we added this sentence. Transformer top surfaces that are horizontal and readily accessible shall be marked to prohibit storage. Now, that was in the 2020 code book. Let's take a look at the 2023 code book. 450.9 says, ventilation has the exact same language, and it was not modified. So keep in mind that equipment like transformers, we rely on the enclosure, the ventilations, openings, etc., for controlling the temperature within that assembly. Don't be placing items on the surfaces. And you got to keep your working space. Very important. All right. So here's a good diagram. You have to think above that transformer as well as in front of that transformer, right? So they define the space requirements in 110 about regarding the working space. So you have a horizontal. You have the dimensions identified clearly for your working space. So you have the width of the working space, you have the height of the working space, and you have the depth of the working space in one. So you have the height is 6.5 feet. Your width is 30 inches, or the width of the equipment. And then you have your 3 feet in front of it, right? So, and that space goes all the ways up. So you have to be careful about when you place equipment. Here's another good example. The width of the working space in front of the electrical is required to be not less than the width of the equipment, or 30 inches, whichever is greater. And so if you have equipment that's up against the wall, etc., you're okay. It's not required to be centered, so it's not like you need a few inches on either side. If that equipment is is against the wall, then you're okay with that. So it doesn't, you do not have to have the working space centered in front of the equipment. So this is an example of your working space. You have working space now. You could argue some of that raceway, some of the conduit might be in the way for the equipment that's on the located on the wall. You have to evaluate every installation with regard to those working space rules. This is about transformers, but you have to think about all of the equipment, because that's a general requirement. Working space is required for equipment. That would apply to the transformer and that equipment that's on the wall. Now here's a violation. Now in this case here, you may have the transformer and then equipment located above it, and that infringes on the working space for the equipment above it. Maybe not the transformer. Transformer might be fine. But the moment you put that transformer below this equipment, you went from complying with working space requirements to not complying with working space requirements. Remember, there's in 110.26A3, we cover your height of the working space, and we give you some rules regarding some exceptions. The workspace shall be clear and extend from the grade floor or platform to a height of 6.5 feet. Or the height of the equipment, whichever is greater within the height requirements of this section. Other equipment or support structures, such as concrete pads associated with the electrical installation and located above or below the electrical equipment, shall be permitted to extend not more than 6 inches beyond the front of the equipment. So as long as I don't extend within 6 inches from in front of the equipment, beyond 6 inches, then I'm fine. If I extend further than 6 inches, then I have an issue. And a transformer located down below that wireway depth of 10 inches, it could be 10 inches, but if the extension beyond the panel is less than or equal to 6 inches, I'm okay. But that transformer, the moment you locate that transformer, now I've exceeded that 6-inch allocation. All right, so be mindful of the working space above or beyond. Meters are permitted to extend into the required space for electrical equipment, and that you'll find as exception number 3 in 110.26A3. Now, if you look at this application here, you have a transformer and an enclosure above it that does not comply for the working space. You've got to think about the electrical worker who needs access to that big green box that's above that transformer. So be mindful of the working space. Equipment foreign to the electric, and so no piping, ducts, leak. So 110.26E1A. 110.26E is titled Dedicated Equipment Space. And it tells you switchboards, switchgear, panel boards, and motor control centers shall be located in dedicated spaces and protect from damage. It doesn't speak to transformers. So 110.26E, dedicated equipment space, all switchboards, switchgear, panel boards, and motor control centers shall be located in dedicated spaces and protected from damage, does not apply to a transformer because it only applies to specific equipment. Now, from a working space perspective for medium voltage, over 1,000 volts, what you get into here is the, remember I said earlier, the requirements around transformers for over 1,000 volts for working space. You have, instead of one section with multiple first level subdivisions, here we're dealing with 3 sections. Workspace about equipment is 110.32. 110.33 is your entrance to enclosures and access to working space. That's your egress and access. And then you have 110.34 is your workspace and guarding. So be mindful that, again, if you look at 110.32, 110.32 is, again, entrance to enclosures and access to working space, open equipment doors. So there's references to large equipment, there's references to guarding. But because it's written in a generic nature, it doesn't specifically have equipment in the title, except for 110.32. Well, 110.32 is workspace about equipment. That sends you to 110.34 for the depths, right? And 110.34 is titled workspace and guarding. So your first step, your first stop in your journey around working space for transformers from an over 1,000 volts nominal perspective. 110.31 would be your enclosures, but 110.32, your workspace about equipment. Transformers are equipment. And in there, they talk about the depth as required in 110.34A. So 110.34 has your working space, and there's an actual table in there for you. And then 110.34B is separation from low voltage equipment. Then you have your locked room, you have your illumination requirements, etc. So 110.32, 110.33, and 110.34, in my opinion, are your areas that you're going to want to consider for your working space for larger transformers, medium voltage type transformers. Now let's take a look at Article 450. 450 is separated into 3 parts. Part 1 are your general provisions. Part 2 are installations. And then part 3 is transformer vaults. So go out to your NFPA link and grab Article 450 and take a look at your different parts. Part 1 is general provisions. Part 2 and then part 3 are transformer vaults. So you've got 3 different parts to it. Now, another term that you're going to want to be familiar with when you're dealing with transformers, separately derived systems. When you have your delta to delta, delta Y ground, etc., as long as it's not an auto transformer, things of that nature, you're dealing with separately derived systems. An electrical power supply output other than a service having no direct connections to circuit conductors of any other electrical source other than those established by grounding and bonding connections. That's defining the term of a separately derived system. Now, the separately derived system is one of the reasons why that's really important and critical to understand is when you have that, like a separately derived system, you've got to go to Article 250 to understand your grounding and bonding associated with that separately derived system. It's very important to understand how you treat the neutral, how you derive your neutral, how you derive your grounding electrode conductor and your grounding electrode, etc. How you can tie that system into the grounding for the power for the site and meet the requirements in Article 250 for the grounding and bonding. So be very mindful of when you establish a separately derived system, the requirements that are there to around your grounding and bonding. So just be mindful of that. Now, there's different types of transformers. There's dry type transformers. There's oil immersed transformers. And when you look at the installation requirements in 450, when you think about Article 450, they'll tell you that 450 applies to dry type transformers and oil immersed transformers. They'll tell you that 450 does not cover current transformers. They don't cover dry type transformers that constitute a component part or of another apparatus to comply with the requirements of that apparatus. They don't cover the transformers that are an integral part of an X-ray, high frequency, or electrostatic coding apparatus, nor the transformers associated with Class 2 and Class 3 circuits. Transformers for electric discharge lighting or sign and outline lighting. Transformers for use in power-limited fire alarm circuits, or transformers used for research, development, or testing when you have the proper safeguardings from persons and property, etc. So Article 450 has a specific scope, and you've got to understand when you should or should not apply Article 450, but oil immersed transformers and dry type transformers are both covered by the requirements in 450. And remember, 450 deals with the protection of a transformer. The requirements that you find in Article 450 are around the transformer only, not the secondary conductors of a transformer, not the equipment that is supplied on the secondary of that transformer. The requirements you find in Article 450 are meant for the protection of transformers, okay, and the application of the transformer. Keep that in mind. Also, the terms of accessible, whether they apply to equipment, wiring methods, or the term readily accessible. You'll find the use of these terms in Article 450 and other areas that directly pertain to a transformer, whether or not the transformer has to be accessible, readily accessible, etc. Be mindful of the proper use of these terms in your application of a transformer. So here we go. So I would argue this is dealing with accessible. You'll see a key on this piece of equipment, and in the definition from accessibility perspective in Article 100, we said for readily accessible. Remember, readily accessible speaks to ready access to take actions, and you're not allowed to use tools. Now, a key is not a tool. So we brought that out in the definition that a key is not a tool. So when you see something that has a key, a locked room is still readily accessible. That provisions for the key and to be able to, requiring to unlock the door, whether it be on the door of that enclosure or the door of the room or the front door of the facility, that is still readily accessible. So just be mindful of that. Here's some of your product safety standards. 1310 for Class 2 power units, 1561 for dry type, general purpose, and power transformers, 1562. So these standards and also some IEEE documents help us in the application of the product. And I would point down again the UL guide information. Look at the what used to be the UL white book, which is now product spec. Go out to XPTQ for general purpose transformers. Look at these. Here's a small industrial control transformer, 75 VA type. Insulation. So this is an example of a transformer. Again, transformers can be small and they can be large. All right, various different code sections that you will have to be mindful of. Article 100, you got to remember the definitions. 110, again for all requirements. Article 240 for overcurrent protection of conductors. 240 is where you're going to also find the transformer secondary conductors, right? So whenever we talk about the location in the circuit, 240.21 has a tap supplying a transformer. That's for the primary side. And then you have transformer secondary conductors in Part C, first level subdivision C, 240.21c, transformer secondary conductors. And it talks about various applications on the secondary conductors. Now, it's not the transformer itself, but it's important to understand that Article 450 talks about the transformer. You still have to think about those secondary conductors, whether or not they're being protected. That first piece of equipment, another article that I didn't put up here, 408. Article 408, switchboard, switchgear, and panel boards. 408 will tell you for a panel board. If you look at Part 3 as panel boards, your overcurrent protection in 408.36 specifically says panel boards supplied through a transformer. The overcurrent protection has to be on the secondary of the transformer. And you might say, well, wait a second, Tom, 450 says there's provisions when you don't have secondary protection on a transformer. Well, that's fine. But if you're supplying a panel board, the protection of the panel board is in 408. You got to think outside of the box. You have to make sure you encompass all of the areas in the code that would apply. Grounding and bonding, Article 250. Article 300, wiring methods. Article 310 for conductors. We have to think about the protection of everything else. Remember, 450 deals with the transformer. And if you put that transformer, say, in a hazardous location, you're going to have to go to Chapters 5. Chapter 5 in one of those articles, if you put a transformer out there on a marina, go to 555, and it'll tell you what you can and can't do in a marina application. Can you put a transformer out on up here? Are there restrictions? Are there limitations? So you've got to think about the rest of the code book when you're applying transformers. It's not just about the transformer. Now, 450.3 talks about the requirements for overcurrent protection. But again, this is to protect the transformer itself. If you have over 1,000 volts nominal, it's in 450.3a, and that would be whether you have the primary over or the secondary or both. You could have a 4160 primary transformer and a 480 volt secondary. You would follow the requirements in 450.3a because the primary is above 1,000 volts. 480 to 208 clearly falls in 450.3b's realm because both of those voltages are less than 1,000 volts. You have to make sure you pick the right, whether you're picking table 450.3a or 450.3b. So, things to remember in 450.3, I would argue that you really have to look at, like in 450.3a, you've got to look at the table very closely and read and understand all of the notes. In 450.3a, you have a primary protection over 1,000 volts, and then you have secondary protection, and there's a little item number 2 that tells you that where secondary overcurrent protection is required, when it's required, the secondary overcurrent device shall be permitted to consist of not more than 6 circuit breakers or 6 sets of fuses grouped in one location. Where multiple overcurrent devices are utilized, the total of all the device ratings shall not exceed the allowed value of a single overcurrent device. If both circuit breakers and fuses are used as the overcurrent device, the total of the device ratings shall not exceed that allowed for fuses. If those are panel boards, because of the requirements in 408, I can't land my conductor from the secondary of a transformer in a panel board that has 6 disconnects. It has to land on a main overcurrent protected device. If it's a delta Y ground transformer, there are 2 instances. If it's a single phase or if it is a delta, then I may be able to rely on my primary overcurrent device of that transformer. But other than that, for the majority of the systems that we apply, delta to Y grounded systems, you have to land that conductor on an overcurrent device inside of that panel board or ahead of that panel board, but it has to be on the secondary. I can go from the transformer to a breaker in a box and then feed a main lug only panel board, perfectly fine. But I can't go from a transformer secondary to a panel board as a main lug only with 6 disconnects into it. So be mindful of how you properly apply these overcurrent protected devices, and apply Article 450, and don't erroneously apply the requirements you find in Article 450 to equipment on the secondary. Okay, 450 overcurrent protection is for protecting the transformer only, not the secondary conductors or the primary conductors. The primary conductors, that's Article 240. You protect the conductor at its ampacity, right? So be mindful of the informational notes that you'll find in these applications. Now, you'll find where it says, for example, in 450.3a, you'll see a note 1. And anytime you see that note 1, it says where the required fuse rating or circuit breaker setting does not correspond to a standard rating or setting, a higher rating or setting that does not exceed the following shall be permitted. And they give you 2 conditions. This is in table A. The next higher standard rating or setting for fuses and circuit breakers 1,000 volts and below, or the next higher commercially available rating or setting for fuses and circuit breakers above 1,000 volts. Now, if you go to table 450.3b, you'll see similar language as well, where 125% of this current does not correspond to a standard rating or of a fuse or non-adjustable circuit breaker. A higher rating that does not exceed the next higher standard rating shall be permitted. Where are the standard ratings? That's in Article 240. 240.6 gives you the standard ratings for your overcurrent protection. And we provide a nice little table for you in Article 240. 240.6a gives you a nice table that shows you the standard ampere ratings. Can't go higher than the next standard up. And that's only applicable in certain areas, only where you see that number 1. So for the secondary protection, you have it on the 125%. On the primary protection, you have it on the 125% when you have primary only protection. It's at 125%, but you don't have it whenever you have primary and secondary protection, and your primary, you'll see a maximum of 250%. You don't see note 1. So when you are using a 250%, you can't go to the next higher. You've got to go to the next lower. You've got to be less than the 250%. So be mindful of that as well. Be very careful in the proper application of tables 450.3a and b in that regard. All right, so you've got 450.3a speaking to both and b. You got to make sure that you cover all of your bases. You know, these are your tables. Key thing to remember with overcurrent protection on a transformer is that primary overcurrent device. You know, we're going to increase the size, and we have limitations on how large of a device we can go to for a couple different reasons. When you have that primary overcurrent protected device, we're there to protect the transformer, but you've got to remember that that device has to work in a system as a system. I might have specific needs outside of the transformer inrush current, which would cause it to be higher, but also I've got to think about the fact that I might have other system performance requirements that will drive the line side of that overcurrent protected device, the line side overcurrent protected device of this transformer to a larger device. Selective coordination could be one of those examples. So these tables give you the maximum primary overcurrent protection and secondary overcurrent protection. But remember, this is for over 1,000 volts, and then B is for 1,000 volts and less. These 2 tables are there for protection of the transformer itself, not the secondary conductors, not whatever is being supplied by that transformer. So keep that in mind in the proper application of this, and please pay attention to those footnotes. Now, how about the transformer inrush current? Now, the transformer inrush currents will not last forever, right? So approximately 6 cycles, you anticipate that these will go away. And remember, 1 cycle is 1/60th, right? So 1/60th of a second. So that would be 0.016 seconds is 1 cycle. So you basically want to make sure that your primary overcurrent protected device allows the inrush current of the transformer to energize the transformer, that permits it to flow. And that's why we have to have that higher instantaneous pickup, which will cause higher incident energies downstream of a transformer. This is a really important critical piece of the puzzle to understand. And also, remember that the first energization of the transformer, this waveform will look a little different than the second and third and later, because that first energization, you are magnetized, your hysteresis on the iron, the composition of that transformer. You're going to saturate that transformer. You're going to establish a hysteresis curve for it in that first energization, and then after that first energization. So you may have a higher inrush current on that first energization. So this just goes through, the various examples of overcurrent protection, the sizing, the maximum size of the overcurrent protection, primary only protection, secondary and primary protection. Remember, Article 240, very critical for protection of those conductors. And I would say if you have a panel board on the secondary, 408 is going to be another important area for you to focus on. This is your primary protection only. And again, this is primary protection of the transformer. Remember, we're worried about the transformer itself. There might be other reasons why you have to have a secondary overcurrent protective device. All right, you have your oil filled, you have your dry type. This is on 450.3b, primary protection, 9 amps or more, is at 125%. You can go up to 250 whenever you have primary and secondary protection. There's your 250% maximum. And then the secondary has to be 125% or the next higher. When you're at the 250%, you can't go to the next higher, right? So transformer overcurrent protection, again, there's your 250%, there's your 125%. And your typical example, this is what you will typically see. And a lot of these are right next to each other. Anyway, maybe that primary overcurrent device is pretty far away. And it could be that your primary and your secondary equipment are not right next to the transformer. I mean, that's an ideal situation. That would be beautiful if that happened all the time. But you got to remember the proper sizing. Now, I will say that whenever you're whenever you're selecting your equipment around a transformer, in my opinion, the way I like to approach things is that you pick your transformer, you calculate your full load amps, primary and secondary, you understand your available fault current at the secondary from a infinite bus perspective. You get all those parameters established. Then you're going to pick your secondary overcurrent protective device and your primary overcurrent protective device based upon the tables, 450.3a and b, right? You're going to pick those overcurrent protective devices first, and then you're going to select your conductors. Now, your secondary overcurrent protective device, you'll know what the maximum is based upon the tables. You'll know what your maximum overcurrent protective device is, and then you can associate that with a piece of equipment that's on the secondary. For example, you may find out that you can put a 400 amp panel board on the secondary of a transformer, but you're only going to supply a 225 amp panel board, right? So you can feed that panel board with 225 amps worth of conductor protected with a 225 amp overcurrent protective device inside is the main on that panel board, and that's perfectly fine. You don't have to go to the 400 amp if that's permissible, right? But if it is permissible, and say it's 360 amps is the full load amps, or the 125% of the full load amps, you can go to the next higher on the secondary with 400 amps worth of conductor, 400 amp panel board, protected by a 400 amp overcurrent protective device that would meet the requirements of the code. So you just gotta understand your application, know what your maximum numbers are that you don't want to exceed, and then apply pick the right equipment for the secondary of that transformer. Then when you get to the primary of the transformer, the overcurrent device that you pick on the primary may not just be dependent upon the inrush current of the transformer and the maximum overcurrent protective device size. you may need to make sure that you can selectively coordinate through, and you may need to put a larger overcurrent protective device on the primary to handle the inrush currents and to handle the selective coordination through a transformer. And if you want more information on that, we can do that a different day. All right, so then you got to make sure you have you follow the notes. So remember, the notes to a table are enforceable. Informational notes are not enforceable, but notes to a table are absolutely enforceable. So when you look at those tables, pay attention to the notes. You have to pay attention to informational notes, but they're informational only. But the notes to the table where you have the number 1, 2, or 3, and they reference down below, those are enforceable, and they are very helpful to help you understand the proper application of those tables. All right, and a lot of information is going to be given to you straight on the nameplate. So 450.11, let's just take a look. We went from, I just want to make sure, 450. So let's take a look at 450. So in 450, in part 1, you have 450.1 scope. You have the interconnection of transformers. Transformers shall be individually comply with the requirements of this article unless specific provisions allow for interconnection and operation as a single unit. Then you have 450.3. That's your overcurrent protection. We just spoke about the tables. .4 deals with auto transformers, 1,000 volts or less, and the protection of the requirements. Very similar to 450.3. Remember, 450.3 doesn't deal with auto transformers, but 450.4 does, and it tells you how to pick the protection for those transformers. 450.5 is your grounding transformers. And this would be like your zigzags. And I know the first system I ever did work on had what I called a spider on the drawing, and that was in 450. That was a zigzag transformer specifically for grounding. It was a delta system, and they used that to establish that ground. So 450.5 handles the grounding. 450.6 are your secondary ties, 1,000 volts nominal or less. So you have your tie circuits. The circuit shall be provided with overcurrent protection. So that's all of the requirements in 450.5 deal with secondary ties. 450.7 is parallel operation. So when you have transformers that are going to operate in parallel, you got to think about some important details, and those are covered in 450.7. 450.8 is guarding. This is your mechanical protection case, or transformers shall be guarded. So this is your when you want to minimize. You want to have mechanical protection for the transformer. You want to make sure that the case or the enclosure is protected for your dry type transformers, etc. And then if there are any exposed energized parts, how to handle those, and any type of warnings with voltage. So that's how 450.8 is laid out. So again, guarding and just protecting. Remember, 450 deals with the transformer itself. And then 450.9 is ventilation. I think we just talked about this a little bit. You want to make sure that you have proper ventilation. Transformers will have vents at the bottom, and then at the top, you want to make sure that the air can circulate around that core. And you don't want to have anything stacked in front of it, behind it, or on top of it. And they added that language that transformer top surfaces that are horizontal and readily accessible shall be marked to prohibit storage. You don't want to be storing anything on top of these transformers. 450.10 talks about grounding and bonding. Remember, when you establish, or when we talked about it earlier, a transformer could establish a separately derived system. Depending upon the system, you're very likely in the transformer, you're very highly likely you are establishing a separately derived system. So you're going to want to make sure you follow all the rules in 250, and you're going to want to bond all the metal parts, but you're also going to have to deal with the grounding electrode conductor and the bonding of the neutral and the equipment ground at the secondary of that transformer. So be mindful of that, especially if you're looking at backfeeding transformers. If you want to say use an existing transformer to backfeed, it has to be listed for backfeeding, but these are one of the details that really will get you with regard to something that is delta Y grounded, delta on the high side, Y grounded on the low side. When you try to reverse power feed that, you're going to need to rewire that transformer, delta on the primary, Y grounded on the secondary, and those details are important. And one of the reasons why the code changed to say, look, you don't want to just do this on the fly. You want to make sure that that transformer is listed for that type of application. And then we get into 450.11, which is the marking requirements that you see here. There's a lot of information on this nameplate, much of which is going to be used for the details for you to help understand how to select the proper overcurrent protective device and pick the conductors, etc. And even size your transformer. Although there's nothing in the National Electrical Code that says you need to size the transformer for the load, you will need to understand these details to understand what you can and cannot do with regard to this transformer. These are just examples of nameplates. You have all of the key pertinent information on these transformers. You can calculate full load amps, etc. And the connections, as we said, delta, Y ground, Y to Y, delta, delta. A transformer can be configured differently depending upon the application, and you're going to want to make sure it's listed for those types of applications, and you don't want to be rewiring and reconnecting what's in that transformer. That's a really important part. The moment you get into modifying the equipment, you are into a possible field evaluation scenario. All right, so calculating full load amps, man, another very important detail that many people fall on their faces. So remember these equations. Full load amps is simple when it's a single phase application. kVA divided by kV, you got amps. When you get to three-phase transformers, you've got to think about the square root of 3, but also in some of these three-phase transformer applications, you're going to deal with when there's fans that are added and the higher to produce a higher capacity, meaning my secondary, meaning my kVA may change if my fans are on to supply more load. And you have to understand when to use the adjusted kVAs for those applications so that you calculate the right full load amps so that you can pick the right overcurrent devices and to protect the correct equipment. So those are all little details when you get into the larger transformers that you're going to need to be thinking about and understand correctly on how to deal with when you have fans added or additional cooling added to adjust the kVA of the transformer. So be mindful of it. It's a detail that, again, some people miss. All right. We went through markings. We got terminal wiring space, accessibility. All transformers and transformer vaults shall be readily accessible to qualified personnel for inspection and maintenance, or shall meet the requirements of 450.13a, open installations, or B, hollow space installations. You got to be thinking about where you put the transformer and whether or not it's accessible or readily accessible, and understand the definitions. That's why we talked about that in the beginning. You have transformers other than class 2 or class 3 shall have a disconnecting means located either in sight of the transformer or in a remote location. When it is remote, this is in 450.14, the disconnecting means has to be lockable open in accordance with 110.25, and its location has to be field marked on the transformer. Part 2, installation, talks about dry type transformer installed indoors, dry type transformers installed outdoors, less flammable liquid insulated transformers. They talk about non-flammable fluid insulated transformers, oil insulated transformers in 450.26. So as you go down through in the installations, they're dealing with the location of the transformer, the types of cooling capabilities, and then you got to think about if it's oil filled, can I put the oil in that location? All those good things. And then part 3 talks about transformer vaults. The vaults shall be located where they can be ventilated to the outside air without using flues or ducts. Walls, roofs, and floors. They talk about the walls, roofs, and floors of a transformer vault in 450.42. Doorways, vaulted doorways shall be protected. You have a type of door requirements, seals of the door requirements, and accessibility. Ventilation openings, they cover the ventilation. You can think about ventilation. Ventilation is critical for transformers in their application because that means heat. Think, electrical equipment doesn't like heat. Got to be careful and mindful of that. They talk about drainage requirements, water pipes, etc. So those are the requirements, and hopefully we did it justice, going through some of the requirements around transformer applications and gave you a little overview of Article 450. Hopefully we gave you some things to think about with regard to proper transformer installations and all that good stuff. And hopefully you got something out of today's IAEI News Live. So thank you for joining for this session. Thanks for what you do for electrical safety. And I want you to take care, stay safe, and please stay healthy. See you next week.